Today we're going to learn how to factor quadratics with a lead coefficient that's not 1. So to get started, let's look at one that's not too complicated. But the first thing we're going to notice is that we have a number in front. So I'm going to call that A. We have a second number in the middle called B, and a third number called C. Now in previous examples we might have done, we didn't have an A there. It was just x squared or d squared or whatever variable. There wasn't a lead coefficient. So when we have a lead coefficient number like 11, we actually have to do it like a step in the beginning. And so what we do is, instead of just looking for two numbers that multiply to give us the C, the third number, we multiply A and C together. And if we multiply A times C, in this case, we get 11 times 2 is 22. Okay, so our first step, we're going to go ahead and multiply A and C together. And then, just like we would if there wasn't a lead coefficient, we're looking for two numbers that multiply to AC, and then we're looking for the factor pairs that also add to equal B, the middle number. In this case, B is 13. So we're looking for two factors that equal 13. Now, this isn't too hard to guess because 11 and 2 are obviously the two numbers that go there. I just looked right here. Those were the two numbers we started with. 11 times 2 is 22, and 11 plus 2 is 13. Okay, now if we didn't have a lead coefficient, like 11 there in front, we could just jump right to it and write our answer. However, we need to actually do another step. So after we first list factors of AC, find two factors that sum to B, then the third thing we're going to do is split B. Okay, and so if 11 plus 2 is 13, then what I'm going to do now is I'm going to take B and split B into two pieces. 13D is really the same as 11D plus 2D. And so I really am just making that into two separate terms. It's equal to the same thing. 11 plus 2 is still 13. And then I'm going to bring down everything else. So I'm going to bring down the C, and I have plus 2. I'm going to bring down that part, and I have 11D squared. Now when I look at this, it's no longer trinomial. Notice I got four things. So I'm going to do something a little different. I'm just going to try to factor out greatest common factor, not of the whole thing, but rather of the first part and the second part. So I'm going to write that down as our fourth step, factor out GCFs. So what can I take out of both of these? Well, they both have an 11 and a D. So I'm going to pull out the 11D, and what would be left would be just a D plus 1. What can I take out of both in the second parentheses? Looks like just a 2. So I'm going to have 2, and then on the inside, D plus 1. I got great news because these two now match, D plus 1 and D plus 1. And they're in parentheses and everything. So that means I have half of my answer. Remember, when we're factoring, we get parentheses times parentheses. So my first parentheses, I'm just going to pull out the D plus 1, which is what we see in both of them. And so I'm going to just say, all right, we covered that. Now, what do you think goes in the second parentheses? Well, do you see this plus 2 and this 11D? That's going to give us our second factor. So we're done, actually. That is our answer. We've got the factors of this problem are D plus 1 and 11D plus 2. So we listed the factors of AC. So we did 11 times 2 and found 22. And then we found two factors that added to the middle number. 13. And then we took the middle number, we split it into two pieces. So there's step 3. Step 4, we factored out the GCFs. In step 5, we rewrite as the answer. Okay, so that's a lot to take in all on one problem. So I wanted to show you a few examples. I'm not going to write out the whole steps each time, but we're going to be going through this process. We're going to be listing the factors, finding the factors, splitting the middle term, factoring out from each side, and then rewriting as the answer. So hopefully after a little bit of practice, this will feel less weird. This is a detail-oriented exercise, so I see a lot of people that can do this right 8 out of 10 times, and then they're getting mixed up on the last 20%. We want to really practice and pay attention to our details here. In the second example, we have an A, a B, and a C again. And so AC equals 2 times 9. 2 times 9 is 18. Now, I need to look for factor pairs of 18 that equal my middle term. In this case is 9. Unlike the last one, 2 and 9 don't work. And 1 and 18 also doesn't work. So I'm trying to think of the other factor pairs of 18. If it's not 1, it's not 2, let's try 3. 3 times what is 18? 3 times 6, so 3 plus 6 equals 9. And there we have our factor pairs. So I'm going to go ahead and split the middle term, and I'm going to rewrite this as 2x squared plus 3x plus 6x plus 9. So that middle term used to be 9x, but now it is 3 plus 6, which is the same as 9, right? So now we're going to go ahead and draw our parentheses around our sets of terms, but our first part and our second part. We're going to factor out our greatest common factor. In the first one, 2 and 3 don't match, but I can take an x out of both of them. So I'm going to do that. I'm going to take x, then I have 2x plus 3. Then the second one, they don't both have an x, but they both have a 3. So I can do 3, and that will leave me with 2x plus 3. Well, you notice I repeated myself. So the fact that these are the same is good. That means we can move forward. If we got 2 different answers in there, in those parentheses, we'd stop everything and go back because we've made a mistake. This isn't working. This one is working. They match, so I can go ahead and write my answer. 2x plus 3. And then the rest of my answer is what's on the outside here, x plus 3. Okay, so we went through that one a lot quicker. Let's try another example. I'm keeping pretty small numbers here. So when we look at this third example, again, we have an A, B, C. I'm going to label A, B, C. And AC is 3 times 2, which is 6, right? And then you might jump off the page. It's not 1 and 6 equals 5. But that's not true. But 2 and 3 equals 5. So that's what we're going to go with. We're going to go ahead and split the middle term, and we get 3y squared plus 2y plus 3y plus 2. Okay, so all I did was I split the 5y into the 3 and 2. Now we're going to go ahead and draw our parentheses and start factoring. What can I take out of those? Again, 3 and 2 don't match, so I can take out a y. 3y plus 2. What can I take out of both of those? Actually, they don't match at all. So what can we take out? Well, if there's no factors of 2 monomials, then what's one thing we can always take out? 1. So I'm going to take out a 1. I can divide them both by 1. It doesn't really change them, so they stay the same. But I had to have something to pull out. Now I can notice that we do match in here. So we can rewrite our answer as 3y plus 2 and y plus 1. All right. I'm going to start giving you some uglier numbers here. For example 4, we've got A, B, and C. And I want you to notice the negative there. So that definitely is going to change our problem a bit. So when we do this, we're still going to do A times C. And that's 6 times 4, and that gives me 24. And I need to split this into the factor pairs that equal negative 11. So I'm going to go ahead and split it up. 24 has a lot of factor pairs, so I'm going to write them all. I'm going to go 1 and 24. And I'm going to do 2 and 12. And 3, and what is 3? That's 8. And 4 is 6. And 5 doesn't work. And 6 is back to 4. And you see that I'd start repeating here. And I'd go 6 to 4. And then 8 to 3. And then 12 to 2. And 24 to 1. Now, likely, I don't need all these, but the reason I drew them all is to draw the point that we have this repeating pattern. So if you notice, right there, the second set of numbers are the exact same numbers, just flipped. So since we're looking at 24, we're not really concerned with the rest of these. So I'm going to erase them. All right, so we really only have these 4 possible answers. The catch is that none of them add up to negative 11. So if my goal was to add up to negative 11 because b equals negative 11, then we need to come up with a different way to look at this problem. You will notice that 3 and 8 do add up to 11. So that brings up the point that if they both add up to a negative number, well, there are no positive numbers that are going to add up to a negative number. It's just not going to happen. So the number pair that looks like it would work would be 3 and 8, but that would give me a positive 11. So how do I make it into a negative 11? Well, a little trick we can do here is we can say, instead of 3 and 8, what if we had negative 3 and negative 8? If we add those up, we get negative 11. Do we still get positive 24 if we multiply 2 negatives together? Yeah. So when we have a positive number, that's the product, and a negative number, that's the sum, then what we can do is use both negatives. So I'm going to go ahead and split this. This was 6x squared, didn't change that, and the plus 4, I'm not going to change that. But in the middle, I've got negative 3 and negative 8. So minus 3x and minus 8x. Now I'm going to start splitting this up. So I'm going to put parentheses around, but you'll notice something about this. Again, the negative is a problem, because if I cut off my parentheses here, that's not going to work, because the negative and the 8 go together. So I cannot put the parentheses in between there. So I actually have to put the parentheses after the 3x before I hit the negative. Now it looks like what we have here is multiplication because we've got nothing in between there. But really I'm just pulling that in, so it doesn't say minus 8x, it says plus a negative 8x. So I'm going to rewrite this. Now we can actually start pulling out factors. And so when I pull out of the first one, it looks like we can do a 3x out of both of them. And that leaves me with 2x minus 1. Now, remember, we want to try to match this. So we want the next one to also be 2x minus 1. That's what we want. And so the question is, what would we have to take out to go from this to this? Well, we'd be tempted to take out a 4. But if we took out a 4, what would we end up with? Well, we wouldn't end up with a minus 1. We'd end up with a positive 1. We'd end up with a negative backwards. So what we're actually going to take out, since we have this lead negative right here, I'm going to take out a negative 4. So whenever I have a negative in front of my x, I pull out that negative. And so now I get these two match. We got 2x minus 1 and 2x minus 1. And we can rewrite our answer as 2x minus 1 times 3x minus 4. And that's our answer. I have one last example I want to show you. And this one is meant to freak you out a little bit because these numbers are a little bit bigger. We have a negative in there, but I want to show you that there is a trick. And so the trick is, I'm going to put a big star, factor GCF first. So these look a lot bigger than they need to be because I can actually take out a common term out of all three of them before I start doing any of the stuff we've been doing so far. I can take out a 4. So if I divide everything by 4, then I would end up with m squared plus 22m minus, what's 92 divided by 4? That's like 23. And now you'll notice that at first it had a lead coefficient, but it doesn't anymore. So when we work it out from here, we can look for two numbers that multiply to negative 23 and add to 22. So it looks like it's probably going to be 23 and 1, but it's going to be negative 1 because they need to add to positive 22. So when I split this up, I'm going to go ahead and split it just like I would normally. Now we could just jump right to the answer, but I'm going to split it. And we end up with m squared plus 23m minus 1m minus 23. Now from here, we need to take something out of the first two and something out of the second two. So it looks like out of the first two, we can just take out an m. And out of the second two, we can take out a negative 1. And that would leave us with m plus 23 in both of them. Now when I go ahead and finish writing this out, I get 4, m plus 23, and m minus 1. And that's my answer. Now remember, if we don't have a lead coefficient, and we didn't in this one, we could have just jumped right from here straight to the answer. You will notice, however, that that 4 had to come there. So since I factor out GCF first, I need to remember to write the GCF. I'm going to remember GCF, greatest common factor. Today we learned how to factor quadratics with a lead coefficient that's not 1.